Hello everyone, my name is Santanu Samai. I completed my B.Sc from Midnapur College in West Bengal. Currently I am going to join IISc Bangalore for integrated PhD program. In this video, I am going to share my experience at IISc, and basically this interview happens in physical mode at the IISc campus. And first there's in the panel there were 4 professors in the panel. Initially they asked me to introduce myself, and then they asked me about my interesting topic. I said that my interesting topics are quantum mechanics, electrodynamics, classical mechanics and mathematical physics. Then they starts with mathematical physics. First of all, they asked me to draw an arbitrary curve, and I made a simple x sine graph. And then they asked me to take an arbitrary point on that curve, and I took a point P on that graph, and then they asked me to draw a tangent at the point on the curve. And we pointed this point and Q, and also they asked me to draw a perpendicular on the x-axis from P point. And let's say this point is R, and then they asked me what is the nature of the curve if the area of this triangle PQR is constant, then what is the nature of the curve. Then I started the calculations. First of all, we know that area of this curve delta equals to half into base into height. Here base is r cube and height is PR. And if we take this point as an xy point, then this height should be y and this should be x. OR should be x and PR should be y. And so from this diagram we know that this is RQ and PR should be y. Here should be y. Again we know that the slope of this curve, the slope of this tangent line PQ should be, if we take this point phi, then the slope of this tangent line PQ should be tan phi, and it should be equals to dy by dx. And if we take the internal point theta, then from this diagram we can write that theta plus phi should be 180 degree, and phi should be equals to 180 degree minus theta. Then we put the value of phi here, then tan of 180 degree minus theta should equals to dy by dx, and now it should be tan of theta equals to dy by dx. And basically tan theta, from this curve we can write that tan theta is the height by base, and here height is PR. So it will be PR and base is r cube from the diagram, and basically it will be equals to dy by dx, and we know that dr equals to y, so minus of y by r cube equals to dy by dx, and we get the value of r cube equals to minus of y by dy by dx. Put this r cube value here, we get half of minus of y square by dy by dx, and dy by dx equals to minus of y square by 2 into delta, and dy by y square, if we take this y square here, and we get minus of dx by 2 into delta. We know that the area of the triangle is constant, so delta should be constant. So if we integrate on the both side, then we get minus of 1 by y equals to minus of x by 2 into delta plus some integration constant, and we get that y equals to 1 by x by 2 into delta minus c, and this is the final answer. Then Professor B asked me some question on quantum mechanics. He asked me write down the potential of an isotropic two-dimensional harmonic oscillator of frequency omega. Potential for two-dimensional harmonic oscillator, it should be equals to half m x square for x component, half m omega square x square plus half m omega square y square. And then he asked me write down the Hamiltonian of this harmonic oscillator. We know that Hamiltonian H equals to kinetic energy plus potential energy, and here kinetic energy should be equals to px square by 2m, where m is the mass of the particle, and py square by 2m plus potential energy as it is half m omega square x square plus half m omega square I square. Then he asked me write down the energy form in the form of nx and ny, and this is like that E of nx and ny should be equals to nx plus half h cut omega for x component, and it should be, and for y it will be equals to ny plus half into h cut into omega, and it is basically nx plus ny plus 1 h cut omega. And then he asked me next questions, find out what is the energy and corresponding degeneracy from ground state to the third excited state. We know that energy E nx ny equals to nx plus ny plus 1 h cut omega. For ground state, we know that nx plus ny equals to 0, means nx equals to 0 and ny equals to 0. So energy will be only h cut omega and its degeneracy should be 1 and d equals to 1. And for fast excited state, we know that nx plus ny equals to 1, and so we can write nx and ny, nx equals to 0 and ny equals to 1, or nx equals to 1 and ny equals to 0. So we have two combination of nx and ny, and for this state we get the energy E01 equals to E10 equals to 2 h cut omega, and this is the energy of the fast excited state, and we get two combinations of nx and ny. So the degeneracy of the fast excited state should be 2. So degeneracy equals to 2 for fast excited state. And then for second excited state, we know that nx plus ny equals to 2. So the value of nx and ny will be nx equals to 0 or ny equals to 2, or here and or nx equals to 1 and ny equals to 1, or nx equals to 2 and ny equals to 0. So basically we get three combinations of nx and ny. So degeneracy of the second excited state should be 3, and here we get the value of energy E02 equals to E11 equals to E20 should be equals to 3 h cut omega. And last, the energy and the degeneracy of the third excited state. For the third excited state, we know that nx plus ny should be 3. So the combinations of nx and ny will be nx equals to 0 and ny equals to 3, nx equals to 1 and ny equals to 2, nx equals to 2 and ny equals to 1, nx equals to 3 and ny equals to 0. So we get four combinations of nx and ny. So the degeneracy of the third excited state should be 4. And energy of this third excited state will be E03, E12, E21 and E30 equals to 4 h cut omega. Then he asked me what is the degeneracy of the 15th excited state. What is the degeneracy of the 15th excited state? We know that for two-dimensional case, the degeneracy for the simple harmonic oscillator should be for nth state should be equal to the n plus 1, where n is the nx plus ny, and it starts from n equals to 0, 1, 2, 3. Here n equals to 0 represent the ground state, n equals to 1 is the first excited state, second excited state, and third excited state, and so on. So for 15th excited state, n equals to 15, so degeneracy should be 16. And he asked me, can you relate the degeneracy expressions with something that you have read before? Initially I got stuck in that question, but finally I told them that for the binomial theorem, we know that the binomial expressions for x plus y whole to the power n should be equals to nc0 x to the power 0 y to the power n plus nc1 x to the power 1 y to the power n minus 1 plus ncn x to the power n y to the power n minus n. Basically here the total number of terms is n plus 1, and if we take x equals to nx and y equals to ny, basically here the total number of terms should be equals to the expressions of the degeneracy n plus 1. Then next professor asked me some questions on relativity. They told me that suppose this is the arc surface and here have some receptor. Here have some receptor, and here a satellite moves with a velocity v. This is the satellite, and this moves with velocity v along these directions, and it emits a signal towards the receptor. With a speed of c at an angle theta with the directions of the velocity. Then he asked me find out the expressions of this frequency at the receptor point if the actual frequency of the wave is new. At that moment I did not give proper explanations and I got stuck in that questions, and then he told me that okay, no problem. And then next professor asked me some questions on electronics. He asked me what is the leakage of the capacitor, means what do you mean by leakage of a capacitor. We know that for a capacitor, we told them that if we take a charged capacitor and if we don't connect this capacitor with any circuit, it becomes discharged. Although it did not connect, it is not connected with the circuit, means it's transforms its charge from one plate to the another plate, means its charge decays automatically, although it is not connected in a circuit. So then he asked me how to measure the leakage resistance of a capacitor. We know that initially if we take a capacitor C, and initially if its charge is Q naught, then the charge at any time Q should be equals to Q naught into e to the power minus of T by R into C. Here R is the leakage resistance of the capacitor and C is the capacitance of the capacitor. And if we take the natural log ln of Q equals to ln of Q naught minus of T by RC, and we know that ln of Q naught by Q equals to T by RC. And we know that leakage resistance R equals to T by C into ln of Q naught by Q. And if we Q naught by Q, and then they asked me how to measure this Q naught and Q, and I said that to measure Q naught and Q we have to make a special circuit for this capacitor, and these circuits will be like that, and it is the capacitor, and this is a battery, and this is a resistance. Let's say suppose its potential is V and its resistance is R1, and here have some key K, and this is the terminal A, and here have some ballistic galvanometer, and this is the B terminal. Initially I connect this key at the terminal A, and then at that moment this capacitor gets charged from this battery, and then we connect this key at the terminal B, when we connect this terminal at B, then this capacitor makes discharge through this ballistic galvanometer, and we know that when we connect this terminal at B, then this ballistic galvanometer shows some deflections, and which is directly proportional to the charge stored in the capacitor. So basically charge at that moment Q should be equal to the deflections shows in the galvanometer. So Q basically proportional to D. Initially we charge this capacitor for 5 minutes to connect this key at the terminal A, and then we connect this key at the point B, and this is the and this ballistic galvanometer shows some deflections, and this is the initial deflections, means D naught, and this is the shows the initial deflections, this is the D naught, and this is basically the initial charge Q naught. And then again we connect this key at the terminal A and charge this capacitor for the 5 minutes, and then this key remains open for t equals to 10 seconds, and then after t equals to t seconds we connect this key at the B terminal. Then at that moment the charge inside the capacitor decays due to this some leakage, and the deflection shows in this ballistic galvanometer will be different from D naught, and this is the deflections at t equals to 10 seconds, and we repeat these expressions, but we repeat these steps for t equals to 20, t equals to 30, and so on. Then we plot t versus D naught. T versus D by D naught graph means we know that Q proportional to D naught, then T by C into ln of, we know that Q proportional to D. So Q naught is the initial charge and it should be equals to the initial deflection. Initial deflection is D naught and Q is the charge at any time t, so it should be equals to the deflection d. And we plot ln of d naught by d versus t graph. Then we get a straight line curve. Then we get a straight line graph. If we draw ln of d naught by d versus t, then we get a straight line curve, because if we take this ln of d naught by d here, then we get that 1 by rc into t, and this is basically a straight line curve expression, and we get a curve like that, and we measure the slope of this curve, and from the slope of this curve we know that slope equals to 1 by rc, and here we can find r equals to 1 by slope into c, and from this we can measure the leakage resistance of the capacitor. Then he asked me why this leakage occurs. What is the main reason of the leakage of the capacitor? I said that the main reason behind the leakage is the impurities of this dielectric medium that has been used inside the capacitor. Usually we take that, but we consider that the conductivity of the dielectric medium should be 0, and conductivity of the dielectric should be 0, but in practical the conductivity of the dielectric is not 0 due to some impurity of the dielectric. So due to some conductivity, some charge from the charge plate will transfer to the another plate through this dielectric medium, and due to this reason the capacitor leakage occurs. And this is my last question, and then he asked me, this is enough for today and you can go. Thank you very much.